This is just another example of doing the graph, so we'll find all of the same information that we did just a minute ago. So starting with the end behavior. Now on this one it's in ascending order, so the information you need for end behavior is going to come from this last term. So your n is equal to 5, so that's odd. Your a sub n, which is your leading coefficient, is -1. So of course that's negative. So if you have the combination of being odd and then negative, it's going to be your right side up and your left side down. Okay, next was x-intercepts. Okay, we're going to have to factor this. Now if you would prefer, you can turn it around. And then you might even prefer to take out the -1. Or you could just go ahead and take out a -x, but I'll just do one thing at a time. Okay, you have a common factor of x, so now I'll have a -x out front. And this will factor x squared times x squared, and we'll have a 3 and a 2. Now I need a +1 in the middle, so plus sign here, minus sign here. Now, neither one of those will factor any further. So you've got -x equals 0, so of course that's just x equals 0. Now when you do x squared plus 3 equals 0, and you have x squared is equal to -3, you're going to take square root of both sides, and you're going to end up with a negative value, or square root of a negative, which is imaginary. So you just throw that out since we're graphing. X squared minus 2 equals 0, so that would be x squared is equal to 2, so x would be equal to plus or minus square root 2. Alright, so let's see, I didn't come back over here. Of course that would be the point 0, 0. Here I have square root 2, 0, and negative square root 2, 0. Alright, so those are my x-intercepts. Now we'll just use a decimal approximation for square root 2. So let's see, I think it's about 1.4. So of course this would be about 1.4, this would be -1.4. Okay, now on the touches and the crosses, this one has a multiplicity of 1, which is odd. So back up here, you've got an understood exponent of 1. So if it's odd, it crosses. Now, these two, I was not able to take these down to two individual factors, but this is to the first power. So you don't go by this, you go by what the power is on the whole parentheses. So that's, again, odd. So these are all crosses. Okay, y-intercept. Remember, you substitute 0 into the function. So 6 times 0 minus 0 cubed minus 0 to the 5th. So that's just 0. So again, that's the point 0, 0. Okay, turning points. At most, n minus 1, and back at the top, n was 5. So in this case, we would have at most 4 turning points. Okay, using this information to graph, piece of paper here. Okay, so I had an x-intercept at 0, 0. Now my other x-intercepts was about 1.4 and -1.4. And if you remember, all of these were crosses. Now my end behavior was the right end is up and the left end is down. Now I'm kind of lining like this up with the last x-intercept here and this one with this one, because we know once we're done with those x-intercepts there's not anything outside of that. Alright, so connecting this up, I do have to cross. Now I'll go up some height here, we're just not going to worry about exactly, because I'm going to have to come back down and hit this point. I cross again, so I'm going to dip down some amount again, but I'll have to come back because I've got to come back and get this point, and I cross again, see which ends with that end pointing up. So of course those are easy to check when you're finished because you can just graph them in your calculator.